In this video, we're going to talk about z-scores, which allow us to be really specific about the data points that we investigate in their relationship to the normal curve. A z-score is the number of standard deviations a data point is from the mean of the data set. That's kind of a mouthful, but I think the formula will help a lot here. Z-value equals the data point minus the mean divided by the standard deviation. Let's take a look at that formula and what it does for us. So in the numerator here, we're doing the data point minus the mean. What we're doing there is we're finding out how far is a data point from the mean. What's the difference between the two? And that's why we subtract. Once we find that difference, we divide by the standard deviation to find out how many standard deviations away from the mean that data point really is. And that's how we're going to calculate z-scores. iqScores are a data set with a mean of 100 and a standard deviation of 15. Calculate the z-score for an IQ of 107. Round your answer to the nearest tenth. An important note here is we are going to round z-scores to the nearest tenth. That'll be standard for us. In this situation, we're told that the data set has a mean of 100 and a standard deviation of 15. Remembering back to the way that we calculate a z-score, it's the data point minus the mean divided by standard deviation. So let's do that here. The z-score for an IQ of 107 is going to be the data point of 107 minus the mean of 100 divided by the standard deviation of 15. We'll subtract on top and wind up with 7 divided by 15. And then we'll go ahead and do that division. And when we do that division, we get 0.4666 repeating. We are going to round our z-scores to the nearest tenth. So we'll find the tenths place. We'll look one space to the right. Since that number is 5 or bigger, we're going to round up. And the z-score for an IQ of 107 is 0.5. It's normal to think, okay, great, I found the z-score. What does that do for us? We'll take a look at that next. This is a table of areas under the normal curve for different z-scores. And what this table does is it gives us the area to the left of a z-score. So in this chart, we can see a whole bunch of z-score columns and areas that go with them. What this means is if I have a normal curve, if I have a normal curve, that's not very good, let me do better. If I have a normal curve and there's my mean, and I have a z-score, for example, the one we just found a minute ago of 0.5. That's a half a standard deviation above the mean is what that positive number is going to mean. A positive z-score is going to be to the right of the mean. A negative z-score is going to be to the left of the mean. The one that we calculated a few minutes ago was z was equal to 0.5. And so that's where it would be located on our normal curve. What this table does is it gives me the area under the curve that's to the left of that z-score. So in my table, I go and I find 0.5 as a z-score, and I see this decimal number associated with it. That decimal number here is 0.6915. Rather than reporting the area under the curve as a decimal, we're going to report it as a percent. So we're going to move the decimal over 2 places. And what this tells us is that 69.15% of the data would be to the left of a z-score of 0.5. So 69.5% of the data would be to the left of a z-score of 0.5. Let's see how that could be used in a problem. What percent of IQ scores are below 119. So the first thing we want to do here is identify the fact that since we're dealing with IQ scores, our mean is 100 and our standard deviation is 15. We're interested in the point 119. That's our data point. So if I sketch out a normal curve and I've got my mean of 100, and then what I'm interested in is a point over here at 119. What I want to know is what percent of IQ scores are below 119, which is really saying what's the area to the left of 119 under the normal curve. The way that I'm going to find that is by calculating the z-value for a data point that's at 119. So I've got 119 minus 100 divided by 15. That'll be 19 divided by 15. When I do 19 divided by 15, I get 1.26666 repeating. We are going to round our z-scores to the nearest tenth. So I'll find the 10th place and look one space to the right. Since that number is 5 or bigger, I'm going to round up, and my z-score is 1.3. That's good. This question asks me, what percent of IQ scores are below 119? We found out that 119 corresponds to a z-score of 1.3. So we'll find 1.3 in our table. We'll find the decimal value that goes with it, and that's 0.9032. We're going to report the percentages. So instead of as a decimal, we're going to move that over 2 places. And 90.32% of the data is to the left of 119. So what percent of IQ scores are below 119? 90.32% of them are. Let's look at another one. What percent of IQ scores are above 102? So here we're working with IQ scores again. So our mean is 100, our standard deviation is 15. If I were to sketch a normal curve, I've got my mean in here at 100. And then this time the question says, what percent of IQ scores are above 102? So I put 102 on my curve, and I want to know what percent of the scores are above 102. Well, that means to the right of 102. The table I've got is going to give me the area to the left of 102. So I'm going to have to do one extra step in order to find the area that's above 102. But the first thing we'll do is find our z-score. So our z-score for 102 is going to be the data point minus the mean divided by standard deviation. So that's 2 out of over 15. I have 2 over 15. When I divide, I get 0.133 repeating. Rounding that to the nearest tenth, I'll look one space to the right. That's 4 or lower, so I'm going to round down and have 0.1 as the z-score. So I know what the z-score is, so I can use my chart to find 0.1, and this gives me the area to the left of that value. 53.98%. So 53.98% of the data is to the left of an IQ score of 102, but I need to know how much of the area is to the right. Well, all of the data under here would be 100% of it. And if I have 100% of it and I subtract off the part that's to the left, then what remains is the part that's on the right. And that's exactly what we're going to do here. So we're going to say that 100% of the data minus the percent of the data that's to the left will give me the percent of the data that's to the right of a score of 102. And that'll be 46.02%. So what we just found out is that 46.02% of the data is to the right of a score of 102. So what percent of IQ scores are above 102? 46.02% of them are. Let's look at another one. What percent of IQ scores are between 102 and 119? So this one's a little different. This is between 102 and 119. You're probably pretty comfortable with the idea that we've got a mean of 100 standard deviation of 15. And we've actually already calculated the z-scores for these two. The z-score for 102 was 0.1. The z-score for 119 was 1.3. So we'll keep those in mind as we go through this one. Now, what I want to know is what percent of the scores are between 102 and 119. The way that we're going to find that is we are going to find the area to the left of 119. Then we're going to find the area to the left of 102, and we're going to subtract. And when I subtract off the area that's to the left of 102, what I have remaining is the area between those two scores. So let's go ahead and do that. We know our z-value for 102 is 0.1. So the area to the left of a score of 102, area to the left of 102 is going to be 53.98%. The area to the left of 119 is going to be, let's see, that's a z-value of 1.3. So that's 0.9032 or 90.32%. And so what I want to do is I want to say if 90.32% of the data is to the left of 119, and then I subtract off the area that's to the left of 102, that leaves me with the area in between. And so that's what we'll do. And we'll do 90.32% minus 53.98% to find out that the percent of the data that's between those two scores is 36.34%. What that means is 36.34% of IQ scores are between 102 and 119. Let's take this one step further. If 500 people take an IQ test, how many scores are between 102 and 119? This one's a little different because it doesn't ask for the percentage, it says how many. So what I want to know is how many of the scores are between 102 and 119. Now, just a second ago, we went through all the steps to find out that 36.34% of the scores are between 102 and 119. And so what we're really looking for here then is what is 36.34% of all the people that took this test? And here that's 500 people. So what I want to know is what is 36.34% of 500? And to do that, we're just going to convert to a decimal and multiply. When I multiply those two together, I get 181.7. And I can't really have a fraction of a person or a decimal part of a person. So how many scores are between 102 and 119 is something that we're going to need to round to the nearest whole number. So I'll look one space to the right. That's 5 or bigger. So we're going to round up. And there are 182 scores that are between 102 and 119. One more idea. A person has an IQ that's higher than 99.18 of scores. What is their score? So what we're doing here is we're trying to find the IQ for somebody that has an IQ that's higher than 99.18 of all the scores. So this time we already know the area. What we've got here is, here's my normal curve, and this person's score, I'm not sure where it is just yet, but there's 100. I know it's a really high score because it's above 99.18 of the score. So it's over here somewhere. And what we're saying is that 99.18% of the data is to the left of their score, whatever their score is. And we're going to go find it. So what I need to do here is I need to find the z-score that corresponds to being above 99.18% of scores. Find that in my table. And so 99.18% corresponds to a z-score of 2.4. So what I know here is my z-score is 2.4. I also know that a z-score is the data point minus the mean divided by standard deviation. And here, I know what the z-score is. I know the mean is 100. I know the standard deviation is 15. I'm just trying to find x. So in this case, instead of plugging in to find out z, I'm going to solve this equation to find x. And I'll set up that 2.4 is equal to the data point that I'm looking for minus the mean divided by the standard deviation. To solve this, we'll start by multiplying both sides by 15. These cancel. And now I've got 15 times 2.4 is 36 equals x minus 100. Our last step will be to add 100 to both sides so that I have 136 equals x. The question said, a person has an IQ that's higher than 99.18% of the scores. What is their IQ score? Their IQ score is 136.